Observability and SRE Part 13. This episode has 12 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. Resume deep dive. DR with Kasten K10. You engineered backup and disaster recovery using VM and Kasten K10 for Kubernetes. How would you test that a Kubernetes native backup actually restores a stateful workload correctly? Here's a strong way to approach it. A real test means actually restoring the backup into an isolated namespace or cluster and verifying the application starts, connects to its restored storage, and serves correct data, not just confirming the backup job completed successfully, since a backup can complete without being genuinely restorable. Kasten K10 policies were tested on a schedule, not just after initial setup against representative stateful workloads, checking both the persistent volume data integrity and any application-level consistency, like database transaction logs, that a pure disk snapshot might not capture correctly. Nice. Let's continue. Question 2. Resume deep dive. GCP migration. You reduced deployment effort by 40% automating CI or CD with Jenkins, Cloud Build, and Terraform, and supported an on-prem to GCP migration. What was the riskiest part of that migration and how did you de-risk it? Here's a strong way to approach it. The riskiest part was typically data migration and cutover for stateful systems, where downtime and data consistency both matter and can't be easily rolled back. De-risked it by migrating in phases, non-critical services first to validate the pattern, running the on-prem and GCP environments in parallel with data replication before cutover, and rehearsing the cutover procedure in a non-production dry run so the actual cutover window was executing a known good runbook rather than improvising under time pressure. Great. Moving on. Question 3. Current market 2026. GKE Autopilot versus Standard. For a platform serving 40+ product teams, how would you decide between GKE Autopilot and Standard mode today, and what operational control do you give up with Autopilot? Here's a strong way to approach it. Autopilot is attractive at that scale because it removes node management entirely, no node pool sizing, patching, or capacity planning, and enforces security best practices by default, which reduces platform team toil significantly. The trade-off is losing fine-grained control over node configuration, custom daemon sets, specific machine types, privileged workloads, and certain node-level tuning aren't available. So the decision comes down to whether any team has a genuine requirement Autopilot can't meet. If not, Autopilot's reduced operational burden usually wins at that scale. Alright, next question. Question 4. Current market 2026. Workload Identity Federation. How would you design keyless authentication from GitHub Actions or another CI system to GCP using Workload Identity Federation instead of long-lived service account keys? Here's a strong way to approach it. Configure a workload identity pool and provider trusting GitHub Actions OIDC token issuer, map specific claims, repository, branch, environment to determine which GCP service account the token can impersonate, and have the GitHub Actions workflow request a short-lived, automatically expiring token instead of storing a service account key as a secret. This eliminates the risk of a leaked long-lived key entirely, since there's no static credential to leak. The trust relationship is verified per request against GitHub's identity provider. Let's keep going. Question 5. Current market 2026. Terraform versus OpenTofu. With Terraform's licensing changes and OpenTofu's rise, how would you evaluate whether to stay on Terraform Enterprise or migrate to OpenTofu for a large enterprise estate? Here's a strong way to approach it. Evaluate based on which Terraform Enterprise-specific features you actually depend on. Sentinel policy as code, private registry, specific enterprise support SLAs versus what OpenTofu's open-source ecosystem now covers. And weigh the migration effort. State format compatibility is generally fine, but tooling, CI integration, and team familiarity need rework, against the licensing cost and vendor lock-in risk of staying. For a large estate, a careful pilot migration of a few non-critical modules first de-risks the decision before committing the whole estate either way. On to the next one. Question 6. Current market 2026. Gateway API migration. GKE is moving from ingress to gateway API. How would you plan a migration from existing ingress controllers to gateway API with zero downtime? Here's a strong way to approach it. Run gateway API resources alongside existing ingress objects during migration rather than a hard cutover, migrating one service at a time and validating traffic behavior, routing, TLS, health checks, matches before decommissioning the old ingress rule for that service. Since gateway API is more expressive, take the opportunity to consolidate routing logic that may have been split across multiple ingress annotations into cleaner HTTP route resources, and keep the migration reversible per service until the whole fleet has been validated on gateway API. Good. Here's another one. Question 7. Current market 2026. Image signing and provenance. How would you enforce binary authorization with SIG-STOR or cosign signed images and SLSA provenance before anything deploys to GKE? Here's a strong way to approach it. Require every image built by CI to be signed with cosign. Keyless signing via OIDC is the current best practice, avoiding long-lived signing keys, and attach SLSA provenance attestations describing the build process. Then configure binary authorization policies on the GKE cluster to reject any image that isn't signed by the trusted CI identity with valid provenance. Roll this out starting in audit or dry run mode to catch any legitimate images that would be blocked before flipping to enforcing mode, since an overly strict policy applied immediately can block legitimate deployments. Nice. Let's continue. Question 8. Current market 2026. GKE Dataplane v2. What operational differences would you expect after enabling GKE Dataplane v2, Cilium-based, especially for network policies and observability? Here's a strong way to approach it. Dataplane v2 replaces the traditional iTables-based kubeproxy with an EBF-based dataplane, which generally improves network policy performance and scalability at high pod or service counts and adds richer built-in network observability, flow logs, per connection visibility, without needing a separate service mesh. Operationally, expect to validate existing network policies still behave as expected since EBF enforcement can differ subtly from iTables in edge cases, and take advantage of the improved visibility to simplify network debugging that previously required manual dump or iTables tracing. Great. Moving on. Question 9. Current market 2026. Config sync at scale. How would you use config sync or Argo CD to enforce consistent policy and configuration across dozens of GKE clusters and thousands of namespaces? Here's a strong way to approach it. Structure a hierarchical repo, or application set in Argo CD, so common baseline policies, network policies, resource quotas, RBAC, are defined once and inherited by every cluster or namespace, with narrow, explicit overrides only where a team genuinely needs to differ from the baseline. Use config syncs or Argo CD's drift detection and automatic reconciliation to catch and correct any manual changes automatically, and structure the repo so a platform team change, like a new required label, rolls out everywhere with one commit rather than dozens of manual cluster-by-cluster updates. Alright, next question. Question 10. Current market 2026. Docker Build Kit. How would you use Build Kit or builds for multi-arch, cache-efficient, reproducible container builds in a modern CI pipeline? Here's a strong way to approach it. Use Docker builds build, platform Linux or AMD 64, Linux or ARM 64 to produce multi-arch images in one build invocation, and configure Build Kit's cache export or import, cache to or, cache from against a registry cache. So CI runners share build cache across runs instead of starting cold every time, which significantly speeds up builds. Combine this with pinned base image digests and reproducible dependency installs so the same Docker file produces bit-for-bit comparable results, aside from timestamps across different CI runners and architectures. Let's keep going. Question 11. Current market 2026. Node auto provisioning. GKE node auto provisioning versus standard cluster autoscaler. How would you decide which to use for spiky, mixed CPU or GPU workloads? Here's a strong way to approach it. Standard cluster autoscaler scales existing, predefined node pools up and down, which requires you to have anticipated the right node pool shapes, including a GPU pool, in advance. Node auto-provisioning goes further by automatically creating new node pools with the right machine type or GPU configuration on demand based on pending pod requirements, which fits spiky, unpredictable mixed workloads better since you don't need to pre-provision every possible shape. The trade-off is slightly less predictability over exactly which machine types will appear in the cluster, so it's worth combining with resource quotas to bound cost. On to the next one. Question 12. Current market 2026. FinOps chargeback. Leadership wants a chargeback or showback model for GKE and Terraform provisioned infra across 15 teams. How would you design cost attribution without slowing teams down? Here's a strong way to approach it. Enforce required labels. Team, cost center, environment at the Terraform module level so every resource is attributed automatically at creation time rather than relying on teams to remember to tag things manually. And use GKE namespace level cost allocation, available via GKE's built-in cost visibility features, to attribute shared cluster costs down to the namespace or team level. Start with showback, visibility only, to build trust in the attribution accuracy before moving to actual chargeback, and keep the tagging requirement enforced by policy, rejecting untagged resources, rather than a manual checklist that erodes over time. Good, here's another one. That wraps up this episode. Nice work practicing, and see you in the next one.